Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 11 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 474, ones and zeros. So let's read the problem statement. You are given an array of binary strings and two integers m and n. We have to return the size of the largest subset of strings such that there are at most m zeros and n ones in the subset. A set X is a subset of set Y if all the elements of X are also elements of Y. Right. So very easy problem statement. Here if you see m is equal to 5, n is equal to 3. Right. So let's say this is nothing but my set Y. So I need to have one set X, right, which is a subset of set Y if all the elements of X are also the elements of Y, right? And in this, what I need the size of the largest subset of strings, right? Such that there are at most m zeros and n ones in the subset, right? So here m is equal to 5, m means zeros, and n is equal to 3 means 3 ones, right? So here, if I have something like this 0, right? Then let's say 1, then let's say I have 1 0, right? And then let's say I have 0 0 0 1, right? So now if I pick this subset, right, this set X, let's say, so if you see in this, how many total number of zeros I have, right? So we have 1 2 3 4 5, right? M is equal to 5 and we have 5, right? At most means not more than this, right? So we are good, we have 5. Okay, 3 ones, so see here 1 2 3 ones, nice. So we are good, right? And what is the length of this one? 1 2 3 4, so 4 is the output, right? The largest subset with at most 5 zeros and 3 ones is this 1 0 0 0 1 1 0. So the answer is 4. Other valid but smaller subsets include, if you pick this, right? So in this also we have 3 zeros and 2 ones, right? But we need the largest one. Here also this is also valid, right? Because we are not crossing this m and n, right? So here if you see we have 2 ones and 2 zeros, this is also valid, right? But we need largest, right? Here if you see this one, uh 3 ones, 4 ones, right? So ones are 4, right? So it's this condition itself is not valid, right? Is an invalid subset because it contains 4 ones, right, greater than the maximum of 3. That's it. Clear? Now see this example number 2. We need 1 0 and 1 1, right? So this is valid, this is valid if I just pick this. But if I pick this now, this is going to have length 2, right? So I'm going to pick this, right? The largest subset is 0 1, so the answer is 2. That's it, right? Now if you see the constants, so strings dot length, total length is 1 to 600, and strings of I dot length is 100 also, and string of I consists only of digits 0 and 1, and m and n value is from 1 to 100. Okay, so now how I'm going to solve this problem, right? So here we have choices, right? We have choices, right? Whether I want to include this in my subset or not, whether I want to take it or whether I want to skip it, right? If I'm taking it, then these are my next choices, right? So that simply means I am discussing about recursion here, right? Recursion. In a recursion, I have two options, skip and take. If I'm skipping it, then I have to see these choices. If I'm taking it, that simply means I'm using it, right? So I'm going to add it to my subset, right? The length of my subset will be increased by 1, and then I will do the remaining search here in this side, right? So this is nothing but your, you can say, top down approach, top down approach, right? That is nothing but recursive. And then if you want to apply memoization, you can also apply that, right? So I'm going to solve this problem using two approaches. First, I will explain this top down approach, and then after that I'm going to show you bottom up approach. That is nothing but DP approach to solve this problem. Okay, so this is top down, right? Because we are starting from top, right? First this, then after that we are searching in the next elements, then we pick any one, then again we are searching. So from top we are breaking, right? So top down approach, that is nothing but a recursive plus memoization. And then after that I will explain this. Okay, so first let's see this first approach, right? So this is what you have right here. So here, let's say initially you are here, okay, 0 index, 1 index, 2 index, 3 index, 4 index, right? So, and these are your m and n values, okay? So here first you have choice now whether you want to take it or whether you want to skip it, right? All right, so now let's see this like this. Clear? Okay, so first option, let's say first option is skipping, right? And next option is take, right? So now if you are skipping it, if you are skipping it, then next time initially your eye is here, right? Let's say, okay, so next time your eye will be here, 1 0 0 0 0 1 1 1 1 0 0 1 1 and 0, right? Here like this. So next time your eye will be here, right? If you are skipping it. Same way, if you are taking it, then also your eye will be next time here only, right? 1 1 1 0 0 1 1 and 0. Next time your eye will be here, but there is one difference. If you are taking it, right, so that simply means that you are planning to take this element, right? If you are planning to take this element, so in this current element which is 1 0, tell me how many number of zeros are there. Number of zeros is 1. How many number of ones are there? Number of ones is 1, right? This is what you have. So first thing here also you need to check if seriously you can take it or not. You can take it if number of zeros is less than the number of m, right? M is for zeros and n is for ones. So your number of m, right, this number of zeros should be less than equal to m. This number of ones should be less than equal to n, right? So initially m is equal to 5 only, right? Since we haven't taken any string as of now, right? Initially n is 3 only, right? So if you are taking it, right, then that simply means you have added this in your result, right? This 1 0, right? Right? So now your new value of m will be reduced, right? So your new value of m is going to m minus number of zeros. That is nothing but previously m and now number of zeros is 1. So 5 minus 1 is 4. Same way your n value is also going to be reduced, n minus number of ones. So previous value of n is 3 minus number of ones 1. So that is nothing but 2, right? So this is the few changes that we need to do side by side, right? Okay, this is done, right? Now again here for this I also you have two choices, whether you want to skip it or whether you want to take it, right? These two choices you have. Same way here also you have two choices, whether you want to skip it, right, or whether you want to take it, right? So let's say I'm not going to draw complete tree, definitely it will be very big. So let's say I'm going to take this, let's say, okay. So if I'm taking it, so next time 1 0 0 0 1 you have 3 0 1, and then you have 1 1 1 0 0 1, and then you have 1, and then you have 0, right? Like this, 3 1 2 0 1, and here 3 0. Okay, like this you have. Next time if even if you are taking or skipping, next time your eye is continuously moving forward. Next time your eye is here. But now if you are taking it, which element you are taking? You are taking this element now, uh, 0 0 0 1. So in this number of zeros is 3, number of ones is 1, right? So first you have to make sure that this m value, it should be greater than this n value, it should be greater than this value, right? So this is value, right? So now new case, so now new value of m is going to be, previous value of m is 4, 4 minus z, this new number of zeros, so you are going to get 1, and n value is going to be 1 also, right? And now in this case you have something like this. From past you have 1 0 1 0, right? And now you have 1 0 from the past, and now you have 0 0 0 1 in the result, right? So this length is 1, this length is 2. So I'm maintaining the length only here, just for representation. I'm showing that we have these 2, right? But length is 2. If I'm taking it, the length is incrementing every time, okay? 2, right? Now next time here again for this I you have two options. One is skip and one is take. So here in this take case, if you see, number of ones is 4 and number of zeros is 2, and these values are greater than this. So definitely from here we have to exit, right? This is not going to give me valid answer, right? This is not going to give me valid answer. Okay, but here if I'm skipping it, right? So if I'm skipping it, then same case will come, right? Same case. Right now I have result something like this only, 0 0 1, right, of length 2, and my m is still 1, my n is still 1, and now my I is going to move to the next position, right? So I have 1 0 0 0 0 1 1 1 1 0 0 1, then 1 and 0. So now my I is here. Okay, done. Again here I have two options, skip or take. Skip or take. So if I'm skipping it, then there will be some tree. If I'm taking it, then what will happen? Number of ones will be reduced, right? So n is going to become 0, m is going to remain 1, and in the string I have this 1 0 0 0 1, and now one more. Okay, this. And next time what will happen? Next time what will happen? 1 0 0 0 0 1 1 1 1 0 0 1 1 and 0. Next time your I will be here. Okay, now here after this, again you have two options, skip or take, right? So if you are going to take it, right, so then your m is going to become 0, n is going to become 0, and in the final result 1 0, you have 0 0 0 1, you have 1, you have 0. That means your length is 4, and next time your I is going to go out of a bond, right? I is going to go out of bound. Then you, this is nothing but your base case, I can say. This is nothing but base case, right? Then you have to just simply return the output, right? That's it. So this is very easy, right? Recursive approach. So let's write the code for using this approach first. Okay, so what you need to do here, let's not apply memoization first. If there is need, then we'll apply. Okay, first let's solve it without applying memoization, right? Int length is nothing but strings dot length, right? And here just call this return dfs, and here just pass strings, and here pass 0, nothing but starting index, your m value and n value. That's it, right? This is done. Now let's write the code for this dfs method. Private in dfs, and here in this you have to pass all these values, right? So let me just copy this and paste it here, and here you have to pass the index as well, right? Starting index, right? This is done. Okay, now here inside this base case, when no strings left, right? So I can say if index value is equal to this strs dot length, right? That is nothing but base case. So in that case you have to return 0, right? This is what I told you, right? Now here we have to first, whatever the current string, right, we have to count the number of zeros and ones in the current string always, right? So here what I'm going to do, I'm going to write int, let's say zeros, let's name it like this, zeros is equal to 0 and ones is equal to 0 initially, and then you can use enhanced for loop, char c should be small, char c, here strings in this particular index, right? Just change it to char array, and now here inside this just check if character is equal to 0, right? Then zeros plus plus, right? And else ones plus plus. Done. That's it. Okay, now we have two options, right? We have two options. One is to skip, right? So if I'm skipping it, then it's very simple. If I'm skipping it, then I'm going to call this again, the same method. I want this method to do work for me, right? So strings, and now index, next index I'm moving, right? And there will be no change in m and n, right? This is what is happening, right? If I'm skipping it. And option 2 is nothing but take. So if I'm taking it, right? So int take value is 0, right? So we have to only take the current string if it is possible, right? So what I'm going to do, if m value is greater than equal to zeros and n value is greater than equal to ones, right? So in that case only I have to update my take as 1 plus, right? And then again I'm going to call this, right? And here index plus 1, and your m, we have to decrease the number of zeros. So here I'm going to write m minus zeros, and n we have to decrease the number of ones. This is going to be your new n value overall, right? This is what I'm passing here, right? So that's what we need to do, right? And here whatever the result that I'm going to get, right, we have to what we need to do, we have to take the max among them, right? So here I can say return math dot max, right? So here if you see, we have, we will get some result from this side, we will get some result from this side, but we have to return the max result, right? So math dot max of skip and take, skip comma take, that's it. This is the code, recursive code. I didn't apply memoization yet. Let's see if this works or not. So let's run the code. So see, all the test cases has been accepted here. Now let's submit it and see. So see, we are getting time limit exceeded error, right? We are getting time limit exceeded error, right? So definitely we need to apply memoization, right? Because maybe here, if you see in this side, skip I'm doing, in this side I'm take I'm doing, right? So there may be some trees, there may be some trees which I'm solving again and again, right? In this side also maybe I have got something and then again I have skip and take. But if I have solved that particular subtree here, then why do I need to solve it further, right? That is the need. So we have to store the result somewhere, right, of pre-calculated things. So if you see in these pre-calculated things, only three things are changing. One is the index, one is the m value, one is the n value. These three things are changing, right? So I will store the result of these three things which are changing in one memoization array, right? So let's apply the memoization now, right? Okay, so here what you need to do, create 3D memo. Okay, so here I'm going to write integer, and here memo is equal to new integer, and here length, and here m plus 1, right, until 5, right? M is 5, so we have to write 0 1 2 3 4 5, total 6. And if n value is 3, that simply means we can have 0 number of ones, we can have 1 number of ones, we can have 2 number of ones, we can have 3 number of ones. So total for n is equal to 3, 0 1 2 3 4 1 2 3, 0 1 2 3 means total 4 cases, so n plus 1 we need to give, right, since indexing is starting from 0, right? So this, and just pass this memo to this part here, memo, right? And same way copy this, pass it here, and just copy this part, this thing, copy this thing in here, in this part, in this part, right? Now what we have to do here, we are calculating the result, right? So I'm going to store this result, right, in one memo. So here I'm going to say memo, right, and here I'm going to write index, m value and n value, right? And in this I'm going to store this value, copy this, paste it here, right? And this is the thing that I'm going to return here simply, right? That's it. Okay, I'm storing the result here. Now here I will apply one more check. If I have already computed this same tree, already computed, right? So here, if memo of index m and n value, if it is not equal to null, right? So here we are using integer, right? So by default all values are null, right? So if it is not equal to null, that simply means that we have pre-calculated this value somewhere. Then I'm going to simply return this, right? That's it. That's it, right? So let's run the code now and see. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is active now, right? So this is the first part, first approach, right? That is nothing but top-down approach. Clear? So now after this, I'm moving to the bottom-up approach. I'm going to use the same thing, okay? So in this bottom-up approach, what we need to do? So here, what we need our overall outcome can have at most m number of zeros, right? At most m number of zeros, and at most n number of ones, right? So what I'm going to do, I'm going to create one DP, right? So let's say this is my DP, something like this, okay? And here I'm going to write m values. M is equal to 0 if I have at most, if I have 0 number of m's, right? So m is equal to 1 if I have one number of zeros, right? Same way 2 3 4 and until 5, right? This is what I'm planning to do here. 3 then 4, and then 5, right? So this is nothing but m values. M is equal to 3, m is equal to 4, m is equal to 5, right? And n is equal to 3 means we can have 0 number of ones, right? We can have 1 number of ones, we can have 2 number of ones, right? And we can have 3 number of ones, right? This is the meaning of this. Now I have to fill this, right? I have to fill this. Okay, so now here if you see, first thing, I'm creating one DP, right? And my DP is of size here m plus 1 and n plus 1. This is the first thing that you noticed here, right? I can say, right? Now let's say here if you want to pick this 1 and 0, if you want to pick this, right? So if you want to pick this, so how many number of zeros? Number of zeros is 1, right? And how many number of ones are there? That is also 1. Okay. So here if you are picking this, right? If you are picking this, right? So tell me how many number of strings, right? How many number of values in your current set will have, if you are picking this, you are picking it for very first time. So how many number of zeros and 1 you have, right? So at most, right? We are dealing with at most, right? So this is possible na? M1 and N1, this is possible because of this, right? If you are picking this, then this is possible, right? M is equal to 1 and N is equal to 1, right? If this is possible, right? Same way 1 and 2 is also possible na? Right? 1 and 2 is also possible. 1 and 2 simply means at most, right? It is no, it doesn't mean that exactly 2, right? It doesn't mean. So in bottom up approach, we need to fill from here, right? Here just for giving you idea. So but we have to fill from here. So 5 3 result is possible, right? If I just pick this only, so 5 and 3, right? If I just pick, I'm saying if I just pick this 1 0 in my set, right? So see, this is valid set only, right? Because we have number of ones is less than equal to n, and we have number of zeros also less than equal to n. So one result is possible, right? This is a max length as of now, right? Same way this is also possible, this is also possible, right? If I'm picking this is not possible because here it is saying n is equal to 0. This is not possible, right? Same way here this is also possible, 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 this is also possible. All these are possible, right? All these are possible. These are not possible because m is equal to 0, right? Right. So here I'm going to fill my DP array like this. DP, how many, what is the length, how many total length, right, of this set, right, in which I have uh, I can say I number of zeros, at most I number of zeros, and at most j number of ones is possible, right? At most. So here I'm going to fill this dp of I of j value as math.max of dp of I minus j, I of j. That simply means the old value, right? This is nothing but old value, right? If we are not adding, if we are not adding the current, if we are not planning to add this current, then old value, right? But if I'm planning to add this, then what I'm going to do, then here I'm going to write previous time I minus zeros, right? This and j minus ones plus 1, right? I minus zeros is nothing but previous time how many zeros you have seen, right? This current zeros. So right now you are adding 1 0 and 1 1, right? You are adding 1 0 and you are adding 1 1, right? So if you subtract this, so you are going to get the case in which you have I minus zeros, right? So I minus I is let's say 5 here. So 5 minus 1, and j is nothing but 3, right? Here above 3, 3 minus 1. So that simply means you are going to reach to the case where you have 4 number of zeros and 2 number of ones, right? This is the case, right? So we have to subtract this in a previous case, previous best, right? So this is what we need to do, right? So just don't get confused, just see this you are right, this how I filled this values 1 1 1. This is clear, right? How I filled this. Okay, ignore the rest of part, right? Right, as of now. Now after that, if I move here, if I move here, So 0 0 0 1. So I have number of zeros as 3 and number of ones is 1. Right, clear? Okay, now here at this place, right, I I have two options now. I can keep it as 1 0 as the only valid result, or I can keep 1 0 and 0 0 0 1 as the valid result, right? If I'm keeping this, then this value will be changed to 2. If I'm still keeping this, this value will remain 1, right? So if I'm skipping it, if I'm skipping to add this, then existing value of dp of I of j, right? Understood? But if I'm planning to take this, so what I have to do, existing value of this, right? Then what I need to do, uh, first I need to go check this I minus zeros and j is minus ones. So here if you see, number of zeros is 3, right? So dp of 5 minus 3 and j is nothing but 3 minus number of ones is 1. So here you are going to get dp of 2 and 1, right? So that simply means because this time I am adding 3 zeros and 1 1, right? This is what I'm doing, right? This time with the inclusion of 0 0 0 1, I'm adding 3 zeros and 1 1, right? So at most I can have 5 and here I can have 3, right? At most. So now if I'm planning to add this, then I have to check the previous best result when I have two number of zeros and one number of 1, right? So that's what we have got 3 here, 3 minus 1 2 2, sorry. So two number of 2's, right? This is what I am checking previous case. So at dp2 2 what we have, dp2 and 2 we have 1, so 1 plus 1, so here it is going to become 2. So I have to keep max value, so that is why I'm going to change it to 2, right? Right, clear? This is how I'm updating it. Now same thing right here, it becomes 2, so let me write it in a good way. So this is 2 now, right? Now same way here at this place it can be 1, or here I have to see the value at dp of 5 minus 3, that is nothing but 2, and 2 minus 1, that is 1, dp2 1. So 2 and 1 1, so it is also going to become 2, right? This is how I'm going to update. This is going to become 2, right? Now here at this place, same way, 5 and 1, right? 5 and 1, this is not possible actually, right? 5 is possible, but 1 is not possible now, right? The reason is 1 only, this is valid case 1 0, right? But if you add this, then your number of ones will be 2, right? This is more than n, this is not possible. So you will see something like this is also possible, right? If you see m4 and n3 possible, m4 and 3 possible, m4 and 2 is also possible, and I think that's it. M3 3 not possible, right? Here, well, yeah, that's it. This is what you are going to get with the inclusion of this, right? dp array. If you, when I'm going to write the code, when then you can apply this formula and you will see, you will get something like this. So we are filling from bottom, right? So that we don't calculate the same thing again and again, right? So this is done. Now if you see this, right? So here in this, number of ones is 4 and number of zeros is 2, right? So number of ones itself is greater than this value. This definitely we are not going to use it anywhere, we can simply ignore it. Now here if you see this one we can add, right? This one, so only one change is happening, 1, right? So that simply means if you have this, right, you have two options now, right? You have two options. You can keep this as it is, right? You can keep it as it is, or you can have this 1 0 0 0 0 1 and 1 here, right? So here if you notice, this result is possible, right? M is equal to 5, N is equal to 3, 1 2 3, right? And M is 5 1 2 3. Yeah, this is possible, right? This is possible. M is equal to 5 5, and N is equal to 2. No, N is equal to 2. No, N itself is 3, right? Not possible. This is possible, tell me. M4 and N2. N2 is not possible, but this is possible, I think. M4 and 3. M4, 1 2 3 4 and 3. Yeah, this is possible. This is going to become 3, right? And I don't see anything here. M is equal to 3. 1 2 3, 4 zeros are 4 now. So you will get something like this with the inclusion of this. Same way when you are going to reach here, only this value is going to update to 4, this value, right? If you add 0 here, so this is only possible, right? M4 and 3, and 3 means 1 1 2 3, okay, but M4 1 2 3 4 5, no. So you will see this. So in the end you have to return this value, whatever the max value here. whatever the value is here, you have to return it. So this is how you are going to fill all these values, right? Done. So this is what we need to do. Let's write the code, and when you go over the code you will get more clear idea, right? So I'm going to do the same thing here, right? So here in memo we are using 3D, right? Now I don't plan to use this 3D, right? I'm going to use the 2D stuff, right? So here I'm going to write int dp is equal to new int and here I'm just going to pass m+1 and n+1. That's it, right? And I don't need to use this, right? I don't need to use this, all this stuff, right? And here also I don't need to use this. And here what I'm going to do, I'm going to iterate over all the strings one by one, right? So I'm just going to use enhanced for loop for string s in this strs, right? What I'm going to do, I'm going to iterate over all this, right? And now inside this I will just calculate the number of zeros and ones. So this we have to calculate always, right? So I'm going to place it here, right? So this is done. So I'm calculating the number of zeros and number of ones here, right? Now once this is done, then after that we have to update the dp, right? So how I'm going to update the dp, that is also going to be very easy, right? So here I'm just going to return the final dp value. So here I'm just going to write dp at m and n, right? And now here see code is very small now, right? So this is your for loop and this is your string, right? And here you are writing dp. So here you have to write but, so you have to update the dp in the reverse to avoid overwriting results from the current iteration. So here for int I is equal to m, right? I is greater than equal to zeros, I minus minus, and here for int j is equal to n, j is greater than equal to ones, j minus minus, and here dp of I and j is equal to math.max. If you are skipping it, then just take the old value at dp of I j. But if you are planning to take it, right, then in that case what you need to do, previous value where you see the I minus zeros, number of zeros, and here you have to write j minus ones, right? And here in this you have to add one, right? Whatever the value that is there, in this you have to add one, right? This is done. Now after that, here this is done, and now just close it now. And here this thing change it to s. Okay, now let's run it. So see all the test cases has been accepted, right? Now let's submit it. So this is your dp approach. That's it. See, now we are here. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in the comment section. Till then, keep coding and keep practicing. See you in the next video. Thank you. Bye bye.